Hi, welcome to Fun Science with Rohini. Today's experiment is again about Aristarchus and how he measured the size or the diameter of the moon. This is the last experiment about Aristarchus in this series, and the importance of the three videos will be shortly revealed. When Aristarchus decided to measure the size or the diameter of the moon, he observed lunar eclipses. During a lunar eclipse, the Earth comes in between the sun and the moon. And because the sun is blocked by the Earth casts a shadow on the moon. Sunlight is blocked by the Earth and the shadow of Earth is cast on the moon. And Aristarchus knew this. And he came up with an assumption that the shadow of the Earth is approximately equal to the diameter of the Earth. Therefore, he measured the distance traveled by the moon through the Earth's shadow during a complete lunar eclipse, during total lunar eclipse. And he observed that the time taken by the moon to pass the Earth's shadow entirely during the lunar eclipse was approximately 2.6 hours. That means the moon first enters the shadow of the Earth, and then after traveling for some time through the shadow, it comes out of the Earth. And the point at which the moon enters the shadow and then after some time when it leaves the shadow, that distance is considered to be the diameter of the Earth traveled by the moon. So, moon takes approximately 2.6 hours to travel through the diameter of the Earth as observed during a lunar eclipse. Now, Aristarchus also knew that moon takes only 1 hour to travel the distance of its own diameter, and its own diameter is 0.5 degrees. Now, how do you know that the moon's diameter is 0.5 degrees? Because of the angular diameter. A person who's stationed on the Earth and who's looking at celestial objects will get an angular diameter. That is not the actual diameter, but the diameter that you think the object has at that distance. So the angular diameter of the moon was already known back then, and it was 0.5 degrees. And he knew that moon takes 30 days to circle around the Earth. That is, moon takes 30 days into 24 hours to complete 360 degrees of revolution. So, 13 to 24 hours is 720 hours. So, if moon takes 720 hours to complete 360 degrees of revolution, how many degrees will it travel in 1 hour? And that is 0.5 degrees. So, the angular diameter of the moon can be covered by the moon in 1 hour. So, he came up with a reference frame or a ratio wherein the time taken by the moon to cover its own diameter, 1 hour, is taken as T1, and the distance traveled, the time taken by the moon to travel the diameter of the Earth is taken as T2. So T1 by T2 is 1 by 2.6. 1 hour, 2.6 hours. Now he equaled this T1 by T2 to the diameter of the moon and the diameter of the Earth. And 1 by 2.6 equals diameter of the moon by diameter of the Earth, and the value of 1 by 2.6 is 0.3846. Now, at this point of time, he already knew the diameter of the Earth, because Eratosthenes had calculated the circumference of the Earth and it was 40,000. And diameter is circumference by pi, pi. Pi is 3.14. So 40,000 by 3.14 gives you somewhere around 12,739 kilometers approximately. So the diameter of the Earth was already known. So Aristarchus just substituted the values. He wrote diameter of the moon by 12,739 equals 0.3846 or equals 1 by 26. And by resolving this, he got that diameter of the moon is 0.3846 into 12,739. That is somewhere around 4,899 kilometers. And that is how Aristarchus calculated the diameter of the moon, and he said that the diameter of the moon is one third the diameter of the Earth. Of course, this value is way off again. The actual diameter of the Earth, of the moon, is 3474.2 kilometers. This was again way off, but this is the logic that is applicable to all kinds of measurement when it comes to this, to the size of the moon. And this is important because, as we have seen previously, the diameter of the sun is 20 times the diameter of the moon as calculated by Aristarchus, and the diameter of the moon is one third the diameter of the Earth. So if you arrange these bodies according to the diameters or their sizes, the sun is the heaviest or largest, next comes the Earth, and next comes the moon. Using this information, Aristarchus came up with a beautiful theory, and that is heliocentric theory. Earlier, back then, during Aristarchus' time, it was believed that Earth is the center of the universe and all bodies, moon, sun, Mercury, Venus, Saturn, Jupiter, all these revolved around the Earth. This is called geocentric theory. Now, Aristarchus, after measuring all this and realizing that the sun is the largest object, and then comes the Earth, and then comes the moon, he simply said that it would be logical if smaller objects revolved around heavier objects, because heavier objects revolving around smaller objects would be a little messed up. So logically, he said, heliocentric theory, or sun in the center of the solar system, will be more logical and appropriate to consider than the geocentric theory which was prevalent back then. So Aristarchus was the first to propose heliocentric theory of the solar system, and his experimental proofs demonstrated in our videos supported heliocentric theory. Thank you.